Okay, F1. Now remember, when we read a problem, we're going to try and chunk it. So as we're reading the information, we're going to write it down. So it says a robot probe drops a camera off the rim of a 239-meter cliff. Now what I'm going to do is I'm going to draw a picture because I want to know that this is where motion begins. And this rim is 239, so I'm measuring from here down. So in my given, y, which is the vertical displacement, is negative 239 meters. Now I know if I'm dropping it, the initial velocity is 0. And I also know, so then it says where the free fall acceleration. So this is not Earth, this is Mars, and the acceleration due to gravity on Mars is negative 3.7 meters per second squared. So it says to find A, the velocity in which the camera hit the ground, VF, and then the time required. So I want to find T. So the first thing I'm going to do is I'm going to say, well, what variables do I have? So here's the 3 I'm given, and this is what I want to find. So I have Y, I have VI, I have G, and I want to find VF. So I'll use the equation VF squared is equal to VI squared plus 2GY. Now I want to solve for VF. So I know you like to plug in, but if you rearrange the equation and then just put that giant square root there, you're not going to forget to take the square root at the end. Now VI is 0, so I'll make it disappear. An upward arrow to the right with a little 0 means the whole term goes to 0. Okay? So VF is equal to the square root of 2GY, which is equal to the square root of 2 times negative 3.7 meters per second squared times negative 239 meters. Now what I see is the negative times negative gives me a positive, which I know I need to have a positive underneath a radical. So when I multiply all this out, VF comes out to be positive or negative, because with a square root, you're going to have positive or negative 42 meters per second. Now, because my picture, this is coming down, and here's my sign convention, this is actually going to be negative 42 meters per second, not the positive, because according to my sign convention, the velocity has to be negative because it's going down. Now let me look at my units, because remember, if I carry my units and cancel them, it's a foolproof way to check my work. So I have meters per second squared times a meter underneath the radical, which would be a meter squared per second squared. So when I take the square root of the number, I take the square root of the unit, so it comes out to be meters per second. Is that the correct unit for velocity? Yes. Remember, you have a foolproof way to check your work in physics. Do it. All right, for part B, we want to find the time. So I have Y, I have VI, I have G. I just found VF, and I want to find T. So I'll just use the equation VF is equal to VI plus GT. I'll rearrange the equation to solve for T. So T is equal to VF minus VI over G. Remember, this is 0, so I can get rid of it. So it's just going to be VF divided by G. So it's going to be negative 42 meters per second divided by negative 3.7 meters per second squared. And this is going to come out, remember, time has to be positive, 11.3 seconds. Now let's look at the unit. I have a meter per second divided by a meter per second squared, which is a meter per second times a second squared over a meter. So these cancel, and this cancels with that, and I end up with seconds, which is the correct unit for time. So I know I didn't make a mistake. And that's it. So in a nutshell, today's lesson is just the A's become G's, and then you have to look at the problem and say, because you have to find out something else. If I drop something, the initial velocity is 0. If I throw something up in the air, the final velocity is 0. Okay? So you notice if I draw my little picture like this, it really helps to conceptualize the problem. to help me understand it. Because that will, and you're going to do that all year long.